Okay, ladies and gentlemen, I would like to start first with a little bit of motivation, like why we actually do this research. I think we all know about the good benefit of daylight on human well-being, but unfortunately, daylight is not always available in our building spaces, for example, as we can see in these pictures. But I would still like to have daylight all the time. So what actually, can we not have that all the time? The answer is probably yes. So we are actually proposing this so-called virtual natural lighting solution, VNLS in short. But then of course there are several things we have to consider in mind. For example, what are the properties necessary for making the window? How the human being actually perceive this window inside their spaces, and how, not less important, is how does this solution actually impact the physical environment that we are living in. Our research basically focused a little bit more on these two aspects, so I would briefly talk about these two in short. First thing first, is it a very new idea? Actually, it is not a very new idea. I think in the Middle Ages, the French and Italian artist has introduced this concept of the trompe l'oeil, the trick of the eye, where you think you actually see something behind your walls, of course, but it's actually just a painting. Not only in Europe, in Asia, in Bali, you also have this painting where you think that the people are actually somehow lurking out from the window, but then of course these are just painting. So can we have a bit more realistic solutions? The answer is yes, of course, and we try to classify our solution based on the light and based on the view. So if I try to map all of the solutions we can find in reality to these charts, I would probably have this collection of images. What I would like to stress is on the left-hand side of the chart, we basically see the existing prototypes of the virtual windows we can see and we can touch. And on the right-hand side of the chart, we see that something doesn't exist at the moment. And what is the tool, what is the weapon we use to bridge the gap between those? It's actually computational modeling and simulation that it's our tool. So in this talk, I would probably discuss a little bit about how we use computational modeling and simulation in all of these models and types. I'll start first with one corner, upper left corner, is about the complex view and model the complex view and very diffuse light. What is that actually? It's basically just a light box. So it's just a TLM behind a panel, basically. But what do we have in hand? We have this research of Shin et al. About the subjective glare evaluation of virtual windows. So they put a light box and then they put 10 various images on top of it, and they ask their participants to look onto the window and rate the glare perception. And then they vary also the luminance of the window, etc. But then I'm working on modeling. So how can I say that my model can correlate to their results? Because I don't know how they do with the results. I hope I have my own model. Can I connect that those two things? Other problem is they work with subjective scale from 1 to 4.5. I work with the daylight glare probability, for example, from 0 to 1. So it doesn't match. But fortunately, we can use the semantic scale and we can make a correlation and we can develop this model. So if I have a number that they provide, I can easily convert that into a well-known glare matrix that I produce in my simulation. And then I can compare that with my own model, and I have a pair of values where I can compare each other, and I see, okay, it's quite good, so I have something comparable now. For example, for these two type of images, I can say, okay, so for the 4 first window luminance, I have a very good agreement between my simulation and their own subjective evaluation. So my model can be used for predicting glare perception. So what next? I would like to increase the directionality of my window because this one doesn't have any directional light. So I tried to look into another prototype which has a very good, it's not very good. Let's say the first approach of directional light. I found this one. This thing can display at least three types of sky on it. It's a bit like your view when you're sitting in an aeroplane. You just see clouds outside. You don't see the ground. Yeah? And then it uses a spot lamp to simulate the sun. Of course, the sun is a spot, but yeah, it's not really a spot actually. And how does this prototype perform compared to the real windows? And then we use our model again to see if we can. So let me guide you. So these are the lighting levels as measured from certain distance from the window. If I compare these overcast and partly cloudy modes, okay, the red one is actually the red lines is the real windows. So if you change the virtual windows with the real windows, you can have the red lines, and we see that for these two sky models, we have a better performance of the virtual windows compared to the real windows because the lighting level drops not very fast in the virtual windows as compared to the real ones. But if you have the clear sky, the opposite is true. So the real windows performs better. So there is something wrong in the settings of these virtual windows. So, and that's something we can quickly check by using simulation instead of just doing observation. What next? I will still try to increase the directionality of the virtual window, and I finally built my own prototype and see what happens. These are the things. We have now also ground and sky. It has a larger area. It uses a linear LED lamps for the sunlight simulator. It uses also tiles of LED for displaying the view. This is the slide. So it's the same color, but basically you can also play with the colors, so you can change the properties of the colors of each pixel. So that's also a huge improvement. But how does this prototype compare to the old one? I see the interesting question. Basically, if I just quickly show, the second generation prototype compared very much better compared to the first generation. We have more light distribution now. How about the electricity? It's also measured, and then we see that at the maximum settings it consumes about 650 watts for the generation number 2, and for the first generation, the old one, we see that with only half area of the luminance surface, they consume almost the same energy consumption, so power consumption. So basically, the second generation prototype performs much better in terms of energy consumption, because even the surface area is already 2 times. So we're happy enough. But the question next is how far we can actually go with our simulation. And then we still thinking to improve, and then I would like to see more on my view and also more possibilities to play with the directionality. So then the question to answer is what are the necessary input variables we should consider when we want to design the optimal solution. So we introduce various input variables, and then we try to answer what are the most influential, what are the significance of each of these variables. And we did a sensitivity analysis, so basically we want to see which factors actually influence each output. In a very simplified phrase, I say, the more light output we have, the more daylit space we have in space. That's logical, right? But also the wider the beam angle, yeah, of the light, the more uniform the space, and the less delivered light on the ceiling, but also less discomfort glare. So these things also, let's say, can be observed. But then, of course, the question is how big is actually the influence. So it is not about only the trend, but also about the quantity. So how important is actually all of this in terms of percentage. And then the final throw might be, but your prototype still doesn't have a very convincing view. I would like to have a better view on my windows. So finally we approach the final point. Maybe it's still not the final, but almost. And we come back with these 10 images. We still use the same concept. The only difference is we add an extra layer to display the view. So these small sources will just act as light sources, and the view is given by something else. It's put on top of it. And now we are trying to answer the question of what is the effect of those images on this window. So if we compare, again we do the same procedure. Conclusion is, see these two images, they actually perform very low in terms of the number of space available, I mean in terms of distributing the light, but they are very good in terms of delivering the light to the ceiling. So you can have the impression of having a reflection from the ground if you choose these pictures on top of your windows. And if you just want to have a better or the best space available in daily term, you can just choose the pictures with very bright white objects on the sky. So that's also logical, but again it's about the comparison between each picture. So it's not really about the general term. Okay, so it's after all these techy stuffs, probably here come the most interesting part: frequently asked questions. And this is something I summarized based on my experience. So this is a true questions. First question is, why do I want to replace daylight? Maybe most of you work in artificial light, and so you don't give this question, but other people give this. The answer is big no. You don't want to replace daylight. We are not devil's advocate. I mean, if we can have real daylight from a real window, then please go for that. That's not the main message I would like to deliver. Main message is actually to think about these situations where we cannot have daylight even though we very need that. Think about the people working in the cubicle. Think about the people working in night shift time. Think about the patients in the operating rooms or in the CT scan rooms. They don't have daylight, but they need that. So there should be somebody who would think about that. So it's sort of an emergency plan, yes, but somebody has to think about it. Question number 2, simply a matter of disbelief. I don't believe this is really happened. I was presenting in a conference about virtual windows, and somebody else presenting after me. This person said, I work in daylight, I don't believe in artificial window. Yeah, but does this person know about all of this research, concluding that light gives positive effects even when it has very not sufficient view? We all know about this bright light therapy, I think. We all know about this down simulator. We all know about luminous ceilings for elderly people, for example. They don't have view at all, but they have very good benefit on the human being. That's been proven. But not only that, but also the opposite is true. That view has a positive effect even when it has insufficient light. So even a painting will do. And there's a long-term research about that, for example, from Roger Ulrich. So even a painting can increase the possibility of healing of a patient in a hospital, for example. And we can have both. So why so pessimistic about this? Question number 3. Energy conscious people asking about maybe you're okay. You're okay with that because you're from LED, but why should we invest on such energy consuming things? And I will answer with giving an analogy. Why should we invest on this energy consuming computer? Why not we just use this old typewriter in our office? Typewriter doesn't consume electricity, right? Why should we provide sophisticated HVAC system in our office instead of just using this cheap ventilator? It's all about benefit. So if your solution gives benefit, it's worth to consider. And how about cost? Cost is just a function, but it's all deprecating. It's going rapidly low, time to time. I think it was made in 2000. Now we are 10 years later, so I think it's more okay. So it's getting lower and lower, and we all know this LED technology. So again, why so pessimistic? And then there comes the last straw of skepticism. I don't believe that these solutions will become reality. And I would like to give an example of this mobile phone technology. If I say to you 20 years ago that I can make pictures, I can take a video, I can send an email, I can play Sudoku or snakes or whatever using my mobile phone, what would be your reaction? Probably you will think I'm crazy enough. What a ridiculous idea at the time. Of course, I mean, 20 years ago, we even hardly see people using mobile phone, right? We even though they didn't have that. So that's forgivable. But see what happens 20 years later. Everybody has that. So, I mean, I cannot say really how many years it will take for these virtual windows to be applicable in our building spaces everywhere, anywhere. I'm not in position to judge this. Who are we to judge the future, right? We are not God, if you believe in God. But there is surely a potential on that. So, and it's been proven. So there's a good perspective on that. And the question is, and I would probably let you, ladies and gentlemen, go home with this question: which one is more important now? That we can have a good video game on our mobile phone, we can play Sudoku on our mobile phone, or that we can have very good light and very good view to those people desperately in need. I think you all know the question. I would like to end my presentation with that. Thank you very much indeed.